Every day, on a ship somewhere in the middle of the ocean, dozens of people use the bathroom. They flush, and the waste disappears. There is no municipal sewage system beneath them, no treatment plant on the horizon, no pipe running to shore. Just thousands of meters of open water in every direction. So where does it actually go? Most people, if they think about it at all, assume one of two things. Either it goes straight into the ocean, which sounds alarming, or there's some kind of tank that gets emptied at port. Both of those answers contain a fragment of truth. Neither of them is the full picture, and the full picture is considerably more sophisticated than either assumption suggests. To understand it properly, you need to understand what waste management on a ship actually involves, not just toilets, but gray water from sinks and showers, food waste from the galley, oily bilge water from the engine room, and the regulatory framework that governs all of it. Because a modern ship at sea is, in effect, a self-contained waste processing facility. And it has to be, because international law makes the alternative increasingly difficult. Let's start with scale. A large cruise ship carries between 3,000 and 6,000 passengers plus crew. On a vessel like that, daily waste generation is roughly comparable to a small town. A ship that size produces approximately 500,000 liters of gray water per day. That's water from showers, sinks, laundry, and the galley. It generates around 100,000 to 200,000 liters of black water. That's sewage from toilets. Add to that several tons of solid food waste, hundreds of liters of oily bilge water, and significant volumes of hazardous materials including chemicals, medical waste, and dry, solid waste. Every single category is governed by a different set of regulations, treated by a different system, and disposed of through a different method. On a cargo vessel with a crew of 20 or 25, the numbers are obviously smaller, but the systems are identical in principle. The regulatory burden doesn't scale with crew size. A container ship crossing the Pacific is subject to exactly the same international rules as a cruise ship carrying 5,000 people. The international framework that governs all of this is called MARPOL, the International Convention for the Prevention of Pollution from Ships. It was adopted in 1973 and has been amended repeatedly since. MARPOL divides ship-generated waste into 6 annexes, each covering a different category: oil, noxious liquid substances, harmful substances in packaged form, sewage, garbage, and air emissions. For our purposes, Annex 4, sewage, and Annex 5, garbage, are the most relevant. Under Annex 4, ships are prohibited from discharging untreated sewage within 12 nautical miles of the nearest land. Beyond that boundary, discharge of comminuted and disinfected sewage is permitted under certain conditions. Beyond 3 nautical miles, untreated sewage can be discharged only if the ship is underway and moving at a minimum speed. The idea being that dilution and dispersion reduce the environmental impact. In special areas, the Baltic Sea, for example, which is an enclosed body of water with restricted circulation, the rules are considerably stricter, and discharge of any sewage is prohibited regardless of treatment level. But understanding the regulations only tells you what ships are not allowed to do. The more interesting question is what they actually do. How the systems work mechanically, what happens between the moment someone flushes a toilet and whatever the ultimate fate of that waste turns out to be. On a modern vessel, sewage from toilets enters what is called a black water system. This is a dedicated piping network, entirely separate from other drainage systems on the ship, that carries waste to one of 2 possible destinations: a holding tank or a sewage treatment plant. Which destination the waste reaches depends on where the ship is, what regulations apply, and what equipment is installed. The holding tank is exactly what it sounds like: a sealed storage tank, typically located in the lower part of the ship, where sewage is accumulated until conditions allow for legal discharge or until the ship reaches port and can pump out to a shore reception facility. On smaller vessels operating primarily in restricted coastal waters, the holding tank approach is common. The practical limitation is obvious: tank. Capacity is finite, and on a long ocean passage, holding tanks alone are insufficient. A crew of 25 over a 25-day Pacific crossing generates a volume of waste that no reasonably sized holding tank can accommodate without some form of treatment. This is where the marine sanitation device, The MSD becomes the critical system. On ships that operate in open ocean for extended periods, a biological sewage treatment plant is the standard solution. The operating principle mirrors what happens in a land-based wastewater treatment facility, compressed into a unit small enough to install in a ship's machinery space. Sewage enters the treatment plant and passes through a series of stages. In the first stage, solids are separated from liquids through settling. The solid material, sludge, accumulates at the bottom of the primary chamber. The liquid component moves forward into a biological treatment stage, where a colony of aerobic bacteria breaks down organic matter. These bacteria require oxygen to function, so the system continuously aerates the liquid, maintaining conditions that allow the microbial community to consume organic compounds efficiently. After biological treatment, the effluent, the treated liquid, passes through a clarification stage where remaining suspended solids are removed. The final stage is disinfection. Most systems use chlorination for this. Chlorine tablets or sodium hypochlorite solution are introduced into the effluent, killing pathogens before the liquid is discharged. Some newer systems use ultraviolet disinfection instead, which achieves the same result without introducing chemical residues into the discharged water. The output of a properly functioning marine sewage treatment plant is effluent that meets the discharge standards specified in MARPOL Annex 4, standards that measure fecal coliform count, suspended solids, and biochemical oxygen demand. When those parameters are within acceptable limits, the treated effluent can be legally discharged overboard in permitted areas. It is not clean drinking water, but it is treated to a standard that the regulatory framework considers acceptable for ocean discharge. The sludge that accumulates during treatment is a separate problem. It cannot be discharged overboard. It must be stored on board in dedicated sludge tanks and either incinerated using the ship's incinerator, if the vessel is equipped with one, or offloaded to port reception facilities. Incineration at sea is permitted under MARPOL provided the incinerator meets specific emission standards and is not operated within port limits or in certain restricted areas. The ash residue from incineration can then be disposed of as solid waste. Gray water, water from showers, sinks, laundry, and galley drains is handled differently from black water in many regulatory frameworks, though this is an area where rules have been tightening. Traditionally, gray water was considered less problematic than sewage and was subject to fewer restrictions. In practice, galley gray water in particular can contain significant concentrations of food particles, fats, detergents, and other substances that create environmental problems if discharged in concentrated form or in sensitive areas. Modern vessels increasingly route gray water through the same treatment systems as black water or maintain separate gray water treatment units rather than discharging it directly. Food waste from the galley falls under MARPOL Annex 5 and is subject to its own set of rules. The discharge of plastics into the sea is prohibited entirely, regardless of location. Food waste that has been processed through a food waste comminutor, a grinding system that reduces particle size, can be discharged beyond 3 nautical miles from land in most areas and beyond 12 nautical miles in certain special areas. Unprocessed food waste must be kept further from shore. In practice, many ships retain food waste for disposal at port rather than manage the logistical complexity of compliant at-sea discharge. Oily bilge water from the engine room represents yet another category entirely. Bilge water accumulates naturally in the lowest part of the ship's hull as a result of condensation, minor leaks from machinery, and water ingress. It becomes contaminated with oil, fuel residues, and other engine room substances. MARPOL Annex 1 prohibits the discharge of bilge water with an oil content exceeding 15 parts per million, a standard that requires treatment through an oily water separator before any discharge is permitted. The separator uses a combination of gravity separation and coalescing filters to reduce the oil content to permissible levels. The retained oil sludge joins the other sludge streams for incineration or port disposal. The enforcement mechanism for all of this is the oil record book, and for garbage, the garbage record book. Every discharge, every transfer, every incineration event must be logged with the date, position, volume, and method. These records are subject to inspection by port state control authorities in every port the ship visits. The practical consequence is that improper disposal, dumping untreated waste overboard in prohibited areas, creates a documented gap in the record books that is detectable during inspection. The penalties for MARPOL violations are substantial. Criminal prosecution of officers and companies, multi-million-dollar fines, and vessel detention are all established outcomes in cases where deliberate violation is proven. There have been well-documented cases of deliberate circumvention, the installation of what are sometimes called magic pipes, bypass hoses that route oily bilge water around the oily water separator and directly overboard, with falsified record books to cover the discharge. Several major shipping companies have faced criminal convictions and penalties in the hundreds of millions of dollars as a result of such schemes. The existence of these violations doesn't undermine the regulatory framework. It demonstrates that the framework has enforcement mechanisms with real consequences. The trajectory of regulation in this area is consistently towards stricter standards. The Baltic Sea and North Sea are designated emission control areas with heightened restrictions. Cruise ships operating in Alaskan waters face state-level regulations that are stricter than MARPOL in some respects. The IMO continues to review and update discharge standards as treatment technology improves and as scientific understanding of marine ecosystem impacts develops. So when someone flushes a toilet on a ship crossing the Atlantic, the waste enters a system that is, on a compliant, properly maintained modern vessel, considerably more sophisticated than many people's instinct would suggest. It passes through biological treatment, disinfection, and monitoring before any discharge occurs. The sludge is retained, incinerated, or offloaded. The records are kept. The position is logged. The ocean is not a sewer, and the engineering installed on modern ships, driven by a regulatory framework that took decades to develop, reflects that understanding in practical mechanical terms. The system is not perfect. Enforcement is uneven across flag states. Older vessels operate with older equipment, but the direction of travel is clear, and the gap between what happens on a compliant modern vessel and what most people imagine is considerably larger than the gap between the ship and the nearest shore. That raises a question that follows naturally from all of this. If ships can't discharge waste freely, what happens to everything else that accumulates on a long voyage? The solid garbage, the hazardous materials, the things that can't be incinerated or treated. That's a system with its own logic, and I've covered it in another video.